Alright, so welcome back to another video on Node.js, right? Specifically on Socket. So what I'm gonna do right now is take a closer look at the Node.js course from Zero to Mastery Academy, where here on the Socket section, okay, uh, I'm just going to make a quick recap of the project here, okay? Because after I look at the theory, which I'm going to make a quick recap tomorrow, but right now I'm looking is at the implementation details on this project, right? So how by using a Pong, this multiplayer Pong, which it was created by Atari. It was very popular that back then. Yeah, is this so I'm going to look at this multiplayer Palm overview, and let's apply what we have learned to build a multiplayer Palm game. And if you're not familiar with that, well, this was one of the first video game released in 1972, 3 years later after the ARPANET, right? So ARPANET, which is the precursor of the internet, okay? The ARPANET, it was established. It was established in 1969, okay, as a defense project. This is the ARPANET logical map, March 1976. Where you have this, and how powerful is this? Of course, you look at this and it might look like it might look like if you take a closer look at this, for example, logic gate here, microchip, right? Diagram. When you look at a exactly like this. So when you look at the microchip or the logic gates, or from a microcontroller, the logic gate, and we're going to look at a more nested collection, right? For example, here, a microcontroller. So you have several logic gates that output something. We see something an input, and it expect or it return something, right? So looking at this, and if you're not familiar with this, this is something very interesting to look and to understand, all right? Because now with this, it look like somewhat similar, okay? But once you understand, you say, what the? And again, yes. So Atari was created 3 years after ARPANET, the precursor of the internet. So we're gonna look at this multiplayer Pong game, okay, and review the code that they give us, right? So the TLDR for all of those different functions and uh, capabilities that you can do in this particular game. So when I navigate here to uh, here, and then I run that, for example, open it here, right? So you have is the Pong game, okay, where now computer increase their speed, okay, So now computer increase the speed and you actually have reached unlimited. You reach a bar here. Okay. You reach actually a bar. Because the ball is always launching in the same position. And that's what happened. You know, the ball is launched in the same position. But again, the thing of this is now you're able to see is this palm game and also what the code does. When I open here with VS Code, okay, looking at our pawn game, we already have 16 points over 4, so we're beating in the own game, right? I would also like to see is the, well, yeah, take me to the JavaScript code here. Exactly. So yes, this is all the code relevant to create this multiplayer pawn games against a computer, right? So I will argue that the point here, or the most important concept here is something called the game loop. Whereas, yeah, the game loop. So after I made this code review, the important concept from all of that is something called the game loop, where when you start the game here, you're going to call this, you're going to tell the browser here, I just want to run this computer AI, okay? Then you calculate is when the ball moves, you're gonna paint that, you're gonna check if the ball is within their boundaries, and do that again. You know, this is called the game loop. So every game has a game loop, and this is something important because especially when we talk about sockets, okay, and ask ourselves how can we fetch data that is outside of our control, data that we didn't create, data that might be in their own life cycle. For example, games, trading, or self-driving car. So here, looking at this code review, and again, the important concept here is the game loop that every video game has, from basic games like Tetris to Pong, right? And we're keep winning, man. You're not gonna fucking beat us. um, or more modern games like Fortnite and Minecraft. So, okay. I don't know how much memory it consumes, but once I reach to 100, it'll be okay. Cool. So once I look at that, right, and then how this.
Welcome back. So how will our multiplayer Pong application work compared to our single-player Pong application? What messages will be sent back and forth between the server and the client? How will the two players communicate with each other and coordinate their game? There are a few different strategies that we could take. We could move all of the game logic, including keeping score, the ball movement, and the functions to handle ball boundaries and tracking the ball as it bounces from the side of the screen or the paddle. We could move all of this logic, with the exception of the graphics of the canvas, to the server side, and have the front-end, JavaScript, only really understand how to draw the game and handle the player's mouse movement This would make the game harder to be tampered with. Say if we were concerned about a player cheating. That is, if one player really wanted to win at all costs, and they changed their front-end JavaScript to, for example, set their score to 999, for example. If we had the game logic on the server side, the server would validate this score and reject it, or just send the player the real score and overwrite whatever they put. So having the logic on the server side is definitely safer. But the disadvantage with making this the responsibility of the server is that it puts a much bigger load on that server, which now has to calculate the position of all of the players who are playing Pong in real time, potentially for hundreds of Pong games that are connected to that server, instead of just passing that data along and dealing with asynchronous input and output, which we know Node.js is really good at. If we had hundreds of clients connected to that server running multiple Pong games simultaneously, it could get expensive to run a server that can handle all of that load and still perform well in real time. And from a development perspective, by splitting the gameplay code between the front end and the back end, we make our code much harder to follow and debug. It becomes unclear what pieces of the game logic each side is responsible for, and we can end up with, for example, duplicated functionality between the server and the browser. What's a better alternative? In our case, to keep things simple and functional, we'll keep the gameplay logic to our front-end JavaScript. To ensure that there's agreement between the two players, we'll assign one player as the referee. This player will keep track of the ball position and direction and speed as it interacts with the player's paddles and the game around it. The referee will also keep track of the score for both players, and it will send all of this data to the other player.
So far, the ODR of this is multiplayer Pong message sequence. Important thing. Oh, come on, man. Here, the multiplayer Pong message sequence. For real? Okay. Is that since we want to avoid that a player cheat, since we want to avoid a player cheat, we might take some logic, we might take non-render logic to the server. Okay, it makes sense. So since we want to avoid a player cheat, we might take non-render logic to the server. The trade-off with this approach is now the server is responsible to keep the client update and processing all of this load. And imagine that now handling it for 1,000 users. So we got a scalability problem here, okay, which is this. So we got a scalability problem here. Instead, let's go to so we got a scalability problem here. Instead, let's go to delegate all of this non-render logic to the client and set a referee layer to arbitrate between exactly a referee player to arbitrate between um, between a pawn, a multiplayer pawn game, right? So that's the idea here.
Whenever there's an update. So effectively, only one player, the referee, who is keeping track of all this data, is the source of truth for the game state. The other player is only responsible for updating the referee with their paddle position, as the player moves their paddle around with their mouse cursor. Let's look at how this will look from the perspective of the server as it communicates with each of the clients using the socket.io library. How will the game...
Okay, so and now a diagram of how the server is going to
game start from the perspective of the server as the player moves their paddle around with their mouse cursor. Let's look at how this will look from the perspective of the server.
So, yep. So let's look at how this will work. This might work from the server perspective
as it communicates with each of the clients using the socket.io library. How will the game start? The client will emit a ready event to the server with their player ID to uniquely identify them on that server. Once the server has received the ready message from all of the clients, it will respond by broadcasting to all of those clients a start game event. And it will assign one of the players as the referee. So for one of the players, this flag will be true, and for the other, it'll be false. Now, as the game starts, the client will emit paddle move events as that player moves their mouse around the screen, and it will send the data about where the paddle is to the server so it can update the clients with that data from the other players. So whenever the server receives a paddle move event, it will then broadcast that event in some way to the other players with the updated data. This means that the client will be both emitting paddle move events, but it will also need to know how to respond to paddle move updates from the server. Finally, the referee will emit ball move events to the server, again passing the position and direction of the ball. And when the server receives these ball move events, it will then broadcast them to the other clients. In this case, just the one other player connected to the Pong game. That's it. The rest of the game logic, keeping track of the score and understanding the boundaries of the game, will take place in the clients on the browser. The referee client will be ultimately responsible for keeping track of the true ball position to make sure that there are no glitches in the game if both clients were calculating the ball position slightly differently or with a slight delay. There should only ever be a single source of truth for the most important shared game data. And in our Pong game, that is the position of the ball as you're passing it back and forth, and of course, the score. The benefit of keeping all the logic in the front end is that it makes our socket server a thin server, meaning it's lightweight and allowing us...
Exactly. So the benefit, the benefit of socket.io so the benefit of socket.io, I mean the benefit of letting the browser to handle all of the non-render logic. Okay. So the benefit of letting the browser to handle all of the render logic, render, and some non-render logic like ball movement. And yeah, like ball movement is that is that our server or socket IO server is thin,
All the
small.
logic in the front end is that it makes our socket server a thin server, meaning it's lightweight and allowing
Is our socket server a thin server?
us to potentially expand our game with more complicated logic and to support thousands of users. But let's start with a two-player game first. I'll see you in the next one. Time to get coding. What do we need to do to set up a socket server in Node using socket.io? We're going to start with our single-player Pong game, and we're going to set up our package.json using npm init. We'll call our package multiplayer Pong and set the entry point as server.js. Now that we have our package.json set up,
okay. Where the heck is the other? Oh hell! Where's the event emitter? Wait a minute. Okay. Extract to single player Pong. Okay. Single player Pong. Okay. Okay. Because it's on this folder and style sheets. Right. Okay. So now when you open this folder like that, I'm going to close this. Bye bye. Yes. And open up the terminal using npm init with all the answer as yes. I don't think we're gonna do that because you don't have viewing no install. Okay, you have no install. That's right. But because it's okay. Okay, because we are working on Windows, not on the Windows subsystem Linux. That's different. Okay, that's good.
as server.js.
Oh, of course. We rename that as server.js. Instead of index is server.js.
Now that we have our package.json set up, we're going to npm install and save our socket.io package. And let's just wait for that to install.
Then start socket.
All right, so now that socket.io has been installed, we can create our server.js.
npm.
This is going to be our entry point, where we create an HTTP server that's attached to socket.io. And the most versatile way to initialize socket.io is to first create a plain Node.js HTTP server. So we're going to create our server and require HTTP from the standard Node library.
So then I create here is the server.js. Okay. Because that's a command from Unix, not from PowerShell. So doesn't matter. here, so the most easy way, or the most flexible way to build a server is with a plain server from the require node. You say require http dot create server, right? For this function,
calling create server from that library. Next, we're going to set a port to 3000 and have our server listen on that port. And we can just log that we are indeed listening on the port that we just specified. Now we're going to
begin is now to print that out here, the console of the log, and tells, hey, we're now listening on port 3000.
to require socket.io and assign it to this IO parameter, this IO constant, and we'll attach it to the server that.
So here, now we're going to need to define the constant IO, which is the instance of socket.io. We're going to import that model from the socket.io. We're going to attach that to our server
that we just created. Now that we have our server set up, we're going to use this on function, which comes from the Event Emitter interface that our socket server uses.
Exactly. Now we're going to use is the instance with the on interface from the Event Emitter
to register an event listener. So we're going to listen to
to register an event listener. We're going to register is the connection, which is
the connection event, which our server will receive anytime a user connects to it. And in our callback function, we'll receive.
In the callback function here, so we'll receive is this socket data.
A socket to communicate with the client or the user that just connected. For now, we'll just console.log that a user connected, so we can test our server.
Okay, so right now we're just going to console.log user connected, user a user connected for that. But again, all the things that he's describing here is something important, especially if you want to describe this, if you want to mention that, you want to communicate to others what are the things that you should do for tech savvy or newbies or new to the field, newcomers.
First, create a plain Node.js HTTP server. So we're going to create our server.io. And the most versatile way to initialize.
And this is exactly here. So now we're going to create this, setting up in socket.io. Setting up. What is that, man? Okay. So setting up a socket.io. The most versatile way to create a server
socket.io, create an HTTP server that's attached to socket.io. And the most versatile way to initialize socket I/O is to
exactly. The most versatile um, to initialize socket.io is to import or to create a plain
first
Node
create
server.
a plain Node.js HTTP server.
Is to create a plain HTTP Node.js server. And this is not only the versatile that offers flexibility, but also it for any middleware you want to add to your server. So for example, if you want to add cores, GraphQL, socket.io, right? So creating a plain Node.js HTTP server and then include all of the middleware or libraries that you need to, it makes your life much more easy, maintainable, and scalable.
So we're going to create our server and require HTTP from the standard Node library calling create server from that library. Next, we're going to set a port to 3000 and have our server listen on that port. And we can just log that we are indeed listening on the port that we just specified. Now we're going to require socket.io and assign it to this IO parameter, this IO constant, and we'll attach it to the server that we just created. Now that we have our server set up, we're going to use this on function, which comes from the Event Emitter.
So now we have the so now we have so now we are going to use the IO instance and set the on function
interface that our socket server uses to register an event listener, which comes from the server that we just created. Now that we have our server set up, we're going to use this on function, which comes from the event.
Exactly. So now we're going to use the instance, the IO instance, and set the on function to listen from an event that comes from the Event Emitter class or instance. Emitter class.
Emitter interface that our socket server
Interface. So it comes from the Event Emitter interface.
Uses to register an event listener. So
But on it comes from the Event Emitter interface.
So we're going to listen to the connection to it so we can test our server. Now, if we go to the socket.io GitHub page and we scroll down to this how to use section, we can see that there's a standalone method here, which doesn't require us to create an HTTP server explicitly. So why would we use the more verbose method here that requires more code? Well, we mentioned that this is the more versatile way of initializing our server. It will allow us to potentially later use HTTPS for our socket connection to secure it, or to potentially attach our socket server to an existing Express API.
Exactly. So we are using the the most verbose setup, the most verbose, yeah, we're using is the most verbose IO or socket IO setup for versatility, versatility in case we want to set an HTTPS or attach our socket to an Express app. That is fucking something crucial here, and something also that I have experience with.
It's time to make sure that we didn't make any mistakes and that we can run our server.
Yep. So now to check our server here, we'll do npm start. Now server is here, listening to our own port. Okay.
We're going to do npm install just in case. And let's start our server. There we have it. Next, let's figure out how to connect to our server from a front-end client.
Next, let's figure out how to connect to a socket server from a client.
I'll see you in the next one.
Again, since I have
Welcome
experience
back.
with this, perhaps the terminology and the reasoning behind it's more like how you can explain the approach you're taking here. I have experience coding this real-time app application, but when it comes to other things, other stuff, or when it comes to describe what you are doing, is something that I might lack of some vocabulary, and that's the reason why I'm doing this. So
Connect to our socket server from the front end and make our Pong game full stack. To connect to our server, we're going to need to load the socket.io client library in the browser. Now, we could download this library and save it locally, loading it just like we do our game JavaScript over here. But we can also, if we go to the resources page here, and under links, we can see that socket.io is hosted under multiple different CDNs. So we can take this URL, where it's hosted, in this case, on Cloudflare. We'll copy the equivalent script tag, and in our index.html, just before our game JavaScript, we'll paste this import. So now we have access to the socket.io client functions, which means that in our script...
So now we have on the index here, so now we have is, we should call that is right below the JavaScript, right? No, but in our case, it has to be, right, exactly, right below the body here, or inside the body, and check the integrity for the code that you don't load. Interesting. In cross origin and refer policy for that. Okay. So now we're going to use is that
client functions, which means that in our script.js here, we can connect to our server by saying const socket equals, and we'll create our IO object connecting to a URL on localhost port.
Socket All right. It's going to create our socket. But now with the socket instance, how do we know what the socket instance is? We say that is IO. So let's go to look at how you can use that on the client side. What is the name of that instance? All right. What about no, I need API. Okay. So how you can use that? Query parents, browsing all of it. No. No. Wait a moment. No. Socket.io. Exactly. So how you can use Socket.io on the client side. All right. On the client API. And the way to do that is through global scope. The IO method is bound to the global scope in the standalone build. Right? So if you use it as bundle, it's also available since version 4.3, which is great, and with an import map, which is even better. Okay, so that's right. So we have the client API and the client options. All of this. The IO factory force multiplex, low level engine, add train slash, our the ref. This is low level engine. Manage options, parser the connections timeout, the socket options, acknowledge time, off, and retry. Okay, but for our case, here is just the IO instance. You get the manager, the events that you can listen to, error ping, reconnect, reconnect error, reconnect fail, methods, manager connector, open, reconnection, socket. So you have is the manager and the socket for that. You can listen to events like connect, disconnect, or disconnection errors. Okay, pretty simple, pretty simple. So, since this is a global object on the client side, which is, I don't like that, but in any case, you can access to that, okay? And you're going to pass is the URL for that, you know? You're going to pass is the URL for that, window.location.host. Default window location.host. Okay, default window location.host. But in our case, it's preferable to set that using the HTTP to the local host and port 3000, like this, or without the HTTP. So it has to do with the HTTP. And one of the great things of Socket.io is that since it attempts to establish a WebSocket connection, it will begin with an HTTP. Okay, it will begin doing that with an HTTP and then upgrade the connection to a WebSocket.
3000. And because Socket.io starts with an HTTP connection and upgrades to WebSockets, we can
So now this is on the client side.
set the protocol at HTTP, and it will naturally upgrade. We'll see this in just a second. Port 3000. And because Socket.io starts with an HTTP,
which is this. So on the client side. Blah blah blah. And on the index here, okay, and this will make a pause here. Okay, you make a pause here. Great. Cool. Lesson. No, it's not about the lesson. It's about the CDN, Content Delivery Network, GS. Thanks for that, because now we can access to this. Alright, so on the index.html, you should add the JavaScript library, and on the script.js, you invoke that, right? And because in since socket IO begin with an HTTP connection and then upgrade and then upgrade to a WebSocket
connection and upgrades to WebSockets, we can set the protocol at HTTP, and it will naturally upgrade. We'll see this in just a second. So this should be enough to connect to our server. While we're here, though, let's clean up some of our code. So we're not going to be using the computer AI anymore. So we can remove this computer speed variable. And we'll do a search and remove any instance of that. We can get rid of the computer AI function.
Okay, so here we're going to get rid of that. The computer speed. Okay, and we're going to find any instance of that. We can remove the computer movement.
And remove it from our game loop. And now
remove it from our game loop. So
now we should be able to reintroduce our introduction screen.
So now we need is to introduce the introduction screen. So waiting for another layer, which is this. Pretty basically. When you're here, do this.
Waiting for opponents screen, which will show when the first player loads the game, but the second player hasn't joined yet. And they'll see this waiting for opponent message. Okay, so let's run our server.
Okay, so now it's going to rerun our server. Okay, and if we want to try to connect to that, of course, what about do this here? Exactly. So now we are disconnecting our server, and if we look at here on the server,
And see if we can connect from the browser. So we can see the computer AI isn't working anymore. And if we go in our developer console,
localhost 3000,
and refresh the page, in the Network tab, we can see that
and if we look to this, on the network tab, you can see it's trying to attempt, but we're receiving some course errors that we now need to indicate.
The last request here is this connection protocol form of pulling. We're ready to start to the server. We'll find out more in the next
What we're
one.
getting is this course error because the server in newer versions, okay, from that newer versions of socket, it says, well, in order to do that, you now need to set the origin for that. So look, take a look here at the server, the first parameter, and the second parameter is an object where you pass is the course. In your case is local host. This is local host without the S because it is not a secure connection for now, but for demo purpose on port 3000. So once I run this and I refresh the page here, okay, now it's doing that, okay. So socket.io, so socket.io, and we need to indicate which method we want to receive as well. Which method we want to receive, because yes, he was successful. He don't load that. He now tries to set by sending a request to there. But the issue is that when he sent that request, when he sent that request, all right, it's now the server is sending is upgrade request for that. So you here need to indicate, hey, that you need to also here to indicate is that the methods allowed are the methods allowed are get and post. So when you run your server again, and the last time you now make a request there, now we're still getting that error from there, so we are not unable to upgrade that to the localhost 3000. Okay, to localhost 3000. So we're not able to do that. So localhost 3000. Okay. The server. And you say, well, the method is get and post. So this is the port. We're going to listen here. And for some reason, it's not able to connect. So in backing our code here with the socket.io, we already download that. And we are trying to attempt to make a connections to the server here in port 3000 to localhost. And is not accepting that for some reason. Now listen to this port. Okay, if I reload this, port allowed, not matching. Okay, local host, then the same name here, local host. That's right. So is this. No access control allow origin header is present, but in our case it says, hey, it's not the same. It say, hey, it's not the same. Here.
Automatically without us having to do this connection up connect from the browser.
But now it says that we are not connected to that. Exactly. And it's trying to attempt to connect. So the client is trying to attempt to connect. But the server does not. So the server tells us is like, no,
tab,
no.
we can see
Perhaps no, it's the same. And now when that happens, when you close that and reload this, it's trying to again, but it says course allow origin not match. Course allow origin not match. HTTP, okay. But if I'm creating is my server here, with local host, it wants to create a server, and for some reason, allow headers, potential true, origin to local host if your web app on your server are not served from the same port. So there is no need to do this. For example, and only allow that to happen. Exactly. So now we are connected to that properly. But this is possible to me. It's like, where are you trying to connect? You know what I mean? When you try to connect, because if I pass that parameter, for some reason, course does not work properly. Okay. Interesting. Origin localhost. This also applies to localhost with your web application and your server are not served from the same port. So if I remove this origin and I allow this to run, it connect to that. It upgrade the connection for that. Interesting. Perhaps it's because how Firefox is sending that request. So the Firefox client is sending that request. You know what I mean? If you look at the network here, okay? Yeah, the network here. So now he performed that properly. But if I add the origin here, then I try to connect from here, allow origin mismatch. Allow origin mismatch. Force header. The editing no supporting is force header access control allowed. Exactly. After all, course is a middleware. Mm, mm, mm. The user connect. So okay. That'll be all for this video. Yeah, that'll be all for this video. So I can. Yeah, so that'll be all for this video. Take care. Bye bye.